There is a division of a Greek word wherein this A identifies, that is, it gives the negative condition. It gave only the spectrum of hydrogen atom or hydrogen-like atom, but the complex atom spectrum was failed by him. The angle through which the ray is getting deviated is said to be a scattering angle. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 12, and chapter name is Atoms. Today we are just giving the introduction to the chapter Atoms. So you all know what is meant by atoms. So you have heard about like matter is made up of atoms, correct? So what are these atoms and what does this atom consist of? So atoms are nothing but a tiniest indivisible particle, okay? It is a tiniest particle, and summing up of atoms gives you the matter. So here atom is the smallest entity, or else it can also be called as it is the smallest unit of a matter. The matter is made up of tiny indivisible particles. So the atoms, that is the particles, is not divisible. Further division of these atoms is impossible. So which is the tiniest particle in the universe, that will be called as atoms. Okay. So Dalton is the one who postulated that the matter is made up of atoms. So we have an element, and in that element we'll have certain molecules. Within that molecule we'll have certain atoms, and the atoms is nothing but the tiniest indivisible particles. How was this name given to this atoms? That is, the tiniest particle was called as atoms. But how did the atom name come? It was derived from a Greek word called as atomos. So what is this atomos? So A and tomos. A and tomos. So here there is a division of a Greek word wherein this A identifies, that is, it gives the negative condition. Okay, and tomos is the one that is division. Okay, tomos means dividing, A means a negative condition. What is that negative condition? It is un. Tomos means it is divisible. It is not divisible. Okay, so that it is indivisible particle. Atoms are indivisible particles. That is what it gives, like by the Greek word atomos. Okay, so atoms is the one. It is the tiniest particle in the universe which cannot be divided, and matter is made up of n number of atoms. Okay, so now by this image we'll get to know that atoms is the one which cannot be divided, and it is the tiniest particle in the universe. When that is the case, atoms are having positive charge, negative charge, and a neutral charge as well. How is that? Within an atom there is a presence of certain thing, and that is the nucleus. So nucleus is said to be the one which is positively charged, and it bears certain neutrons. Okay, so protons and neutrons are present in the nucleus which is within the atoms, and there is a particle called as electron. Okay, so this electron is the one which starts revolving around the nucleus. That is the idea which was given by the Rutherford. Okay, so here this is the concept, and what is the concept which you can see from this diagram is the atoms are made up of nucleus. Suppose if this is a nucleus which consists of protons and neutrons, these golden lines are said to be the orbit which orbits around the nucleus. Within that orbit, that is, which orbits around the nucleus? That is, the electron orbits around the nucleus, and this golden lines is a path where it is orbiting. It is same to same as that of the planets which revolving around the sun. Okay, so a galaxy will be called as an atom, sun will be the nucleus, and the planets revolving around the nucleus is nothing but the electron is revolving around the nucleus. Clear? So that is all about your atom structure. So here we have J.J. Thomson is the one who first postulated a model, and that is first atomic model. So he proposed a first atomic model which was known as plum pudding model. The charge of the atoms is uniformly distributed throughout the atom. And which is that charge which is uniformly distributed? That is the positive charge, in which the electrons are embedded in a pudding type. Okay, so electrons are just embedded over here. You can see a negative sign. Electrons are having negative sign, protons are having positive sign, and the neutrons are the one which is neutral in state. Okay, so the positive charges are uniformly distributed all over, wherein this negative charges are just embedded in it, which is called as a plum pudding model concept, which was introduced by J.J. Thomson. And on contradictory to that, Rutherford nuclear atomic model, which we will discuss further, gave that the electrons are not actually embedded, but it revolves around the nucleus, which is at the center of an atom. Okay, so as I told you, in the solar system, how we consider a solar system, that is a sun as a nucleus, and the planets revolve around the nucleus. Planets revolve around the sun. Similar ways we consider here, that is sun is considered to be nucleus. So around the nucleus there is a presence of electron which revolves around it. So there is a orbital revolving around the nucleus. That concept was introduced by Rutherford nuclear atomic model, which was later modified a little, and we got a Niels Bohr who introduced a atomic model in order to study the spectrum analysis of hydrogen atom. But in this case, that is Niels atomic model, it gave only the spectral series of the hydrogen atom, and it failed to give the spectrum of other atoms, that is a complex atoms. It gave only the spectrum of hydrogen atom or hydrogen-like atom, but the complex atom spectrum was failed by him. Next is, due to the failure, Sommerfeld's relativistic atom model was introduced that gave a little bit of modification to Niels Bohr atomic model. Later on, at present, we just use the vector atom model. So this is just the introductory part regarding the atoms, which is necessary for you to study the further things of this chapter, which is precised only to the class 12 NCERT syllabus. So here now we have alpha particle scattering experiment, which was taken up by Rutherford in order to check out the J.J. Thomson's atomic model, that is plum pudding model. In order to check that conclusion, he just used, that is Rutherford just used this alpha ray scattering experiment. Rutherford, with the help of H. Geiger and E. Marsden, he performed the alpha scattering experiment. How was that? The experiment setup was as shown in the figure. He just used a lead cavity. This is said to be the lead cavity, within which the alpha particle, this orange colored ball kind, you can see, so that is the alpha particle. So which particle it is? Alpha particle, which was enclosed within the lead cavity, and a small slit was made on the lead cavity, such that the alpha particles should pass only through that slit and not through anywhere else. Okay, so when the alpha particle passes, it has to straightly come and fall onto the gold foil. So this yellow color structure, that is nothing but the gold foil, which you can see. Okay, so after falling onto the gold foil, what happens was a Rutherford's observation. So later on you will get to know what was the observation. So he used a lead cavity, that is alpha particle emitter, and particle which was used was the alpha particle, and then there was a slit which was made on the lead cavity, through which the alpha particle passes straight through and hits the gold foil, and after which we have a detecting screen, that is zinc sulfide screen we are having, which detects the alpha particle. So this is the experimental setup. So this is also one of the main important concept in this chapter. So consider it as an important concept. So here, this was the experimental setup which gave certain arrows. You will get to know later why these certain arrows are mentioned over here. Okay. Next, what was the thing? So coming on to the setup, how exactly he set up the experiment. So it is consider a source S. A source is considered as S, which is said to be a radioactive source which is placed inside a lead cavity. So source is said to be alpha particle. The question is, why did Rutherford opt for alpha particle? So alpha particle he opted for because the alpha particles are high energy particle which breaks and it passes through any sort of barrier. That is why we use alpha particles, and it is said to be the heavier particles, so that while passing through any structure like plum pudding model, okay, plum pudding model concept was introduced by J.J. Thomson. So while passing through any such kind of an atoms, what happens to the alpha particle? It straightly passes through it. It has got no barriers due to its high energy and heavy particle. It passes, it just breaks down the barrier and passes straight through, and it does not deflect or deviate. This was the concept made by Rutherford, just an imaginary thought. Due to his thought, he opted for the alpha particle, and using this alpha particle, he emitted, that is, the alpha particles are the one which emits alpha radiations. When that was the case, the alpha particles was placed inside the lead cavity, through which there is a small hole which is made, that is a small slit which is made, through which the collimated beam passes and it strikes the gold foil. So why did he use gold foil? And it was the gold foil which was used was very thin. Why was that thin gold foil used? Thin gold foil used here because it consists approximate of 1000 atoms in it. It consists approximate of 1000 atoms in it. That is why a very thin gold foil was used, so that the alpha particle strikes the gold foil and passes straight away without any deflection. This was the condition made by Rutherford. So what happened next? So now the alpha particles, this will be the procedure, which was emitted by the source is collimated into a narrow beam with the help of a slit made in a lead cavity. The collimated beam of alpha particle is allowed to fall on the thin gold foil, which is of certain thickness, which is mentioned over here. Okay, very thin gold foil. The alpha particles scattered in different directions was observed by zinc screen. Here, whichever assumption was made by Rutherford theoretically was practically broken down. Why? Because Rutherford thought that by using a very thin gold foil and alpha particle, we can see to that all the particles passes straight through the gold foil, and without any deviation, it will strike the zinc screen and we can record number of alpha particles. But here, what happened in the sense, here we have got the alpha particles which is passing, and here there is a thin gold foil which has the presence of atoms, which is like plum pudding model, plus and minus, plus and minus. Consider this as a plum pudding model concept. So whichever passed here, few of the alpha particles which is having higher and higher energy, they just, if this is a screen, that is a zinc screen, it passed straight through without any deviation. The one which got the barrier as atoms, that is gold foil atoms was a barrier to it, it just got deviated and few of them passed backwards. That is, it followed the same path as that of the incident particle. So these were the condition. There was deflections, and these deflections are given by this diagram in the arrow mark, representation of arrow mark. Few of them passed straight through it, that is in this way, and few of them just deviated, and that deviation you can call it as either by the repulsive force of the positive charge which is present, and few of them got deviated just because it hit the center, that is the nucleus of that atom, it got deviated. So this is the concept which was undertaken over here. So collimated beam was allowed to hit the gold foil, and the experience was the alpha particle was scattered in different direction, which was absorbed by zinc sulfide screen. Therefore, alpha particle produces flashes and scintillations on the zinc sulfide screen which was observed. Therefore, the alpha particle which produces flashes or scintillations, that was on zinc sulfide screen. Later, they counted the different angles from the direction of the incident beam, that is either the straight direction or else the deviated direction or rebounding direction was calculated. The angle of deviation called as theta. The angle is always mentioned in theta. So here in this case, we just use angle of deviation because the particle, the ray is getting deviated to different conditions, that is to different angles. Deviation theta of the alpha particle from its initial direction is known as scattering angle. The angle through which the ray is getting deviated is said to be a scattering angle. And the graph is obtained by plotting number of alpha particles which is scattered as a function of scattering angle theta. So this number of alpha particles and alpha is given by a symbol this. Okay, that is the symbol in order to mention alpha. So number of alpha particles scattered with the scattering angle theta, we get a graph in this way. It's a curve, okay, in x-axis as well as y-axis. From this graphical representation, following observations was taken place. So what are the observations taken place by this experiment? It is like many alpha particles doesn't undergo collision with the atoms, gold atoms. As a result, the particle passes straight through a gold foil. Okay, so one is no deviation, there is deviation, rebound. So we are talking about three concepts, one with deviation, one without deviation, and lastly it is always rebounding effect. So what are the sentence for these three? During this experiment, Rutherford observed these three conditions and he gave a conclusion in a better way, scientific way. So what was that? Many alpha particles doesn't undergo collision with the gold atoms. As a result, the particles pass straight through. So there is no deflection or deviation, anything over there. Next, only 0.14% of incident particle are scattered by more than 1 degree. Okay, very less number of particles are getting scattered, that is deviated due to the repulsive effect of the positive charge which is present on the plum pudding model of the gold foil. He assumed that the plum pudding model was present in that gold foil. Okay, the same structure was taken up by him. Why did he introduce all this concept of alpha ray scattering experiment? To check whether the electrons are embedded inside a plum pudding model or else is the electron having any other different places. Okay, so the third final point was about one in so many incident beam. There was many incident beam. So about one in that incident particle is deflected more than 90 degrees. So it is like rebounding. There was a rebounding effect which was studied. There was a deviation which was studied as well as no deviation which was studied. So these were the observations made by Rutherford, after which we have features of Rutherford nuclear atom model. By having all these conditions and by looking at the observations made by Rutherford himself in the alpha ray scattering experiment, he gave the certain features of the atom model, that is atom has a small positively charged nucleus. Okay, so if suppose the nucleus was bigger in size, then the deflection would be more and any particles couldn't even pass straight through the screen, that is the gold foil. That is why he considered that the nucleus is made up of a small, very small particles and it is positively charged. The atom has a small positively charges in the nucleus. Secondly, all positive charges of atom and most of the mass of atom are concentrated in the nucleus, which is given over here in this diagram. Positive charges of atoms as well as the nucleus is concentrated in the center. Okay. The nucleus, that is the size of the nucleus, is very much small when compared to the size of the atoms. This dotted lines give you the size of the atoms and the red particle over here gives you the size of the nucleus. By looking at this itself, you can just get into it. That is the size of the nucleus is very much smaller than the size of the atom, wherein size of the nucleus can be in the range of 10 raised to minus 15 or 10 raised to minus 14, whereas the size of the atom can be nearly in the range of 10 raised to minus 10. So, which is very smaller, that is the size of the nucleus. Now, going on to the fourth point, nucleus is surrounded by number of electrons. Okay, so nucleus is the one which is surrounded by number of electrons. It is not like positive and negative electrons. Negative, that is the electrons are embedded together. It is just that positive charges are concentrated at the center as a nucleus and negative charges are the one which starts moving, that is the one which is uniformly spread surrounding the nucleus. So, electrons revolve around the nucleus in a circular orbit. So, it has got a orbit over it. That means the electrons are the one which revolves around the nucleus and due to the electrostatic force between them. So, that is all about the concept of Rutherford. That is the features of Rutherford. Okay. So, next is alpha particle trajectory. So, what is there in the presence of alpha particle trajectory? Here, Rutherford gave an experiment, that is alpha ray scattering experiment. In that experiment, he found that the incident particles move in different direction and that path was mentioned over here and the explanation was done only to those paths taken by the incident beam of the alpha particles. So here, alpha particle trajectory, we study about the incident beam of the alpha rays. So here we have alpha particle 1, call it as 2, 3, 4, 5, 6, 7 and 8. These are the alpha particles path taken before hitting the target nucleus which was present in the gold foil. Okay, which was our target? Gold foil was our target. So, this will be the initial condition and this will be the final condition, that is the target nucleus. So, suppose you consider only one alpha particle which is moving, that is the first alpha particle which is taking the direction towards the target nucleus. There is a presence of D which is very minute. So, I'll just redraw it. So, this is the first incident particle. So, we have our target nucleus over here. So, there is certain distance where the alpha particle stops and it doesn't approach near. So, that distance is called as distance of closest approach. That distance is called as distance of closest approach, wherein your kinetic energy at this point is said to be 0, which is completely converted to potential energy. So, in the first particle, that is first alpha particle, as it approaches the nucleus, at certain stage, that is at certain distance, your kinetic energy becomes 0, which means to say that it is completely converted into potential energy because energy is neither created non-destroyed, but it can be transferred from one form to the other. So here there is a transformation from kinetic energy to the potential energy. That is why this is called as a distance of closest approach. So if they ask you what is meant by distance of closest approach, you can just answer it this way. That is when the alpha particle approaches the nucleus at certain distance, the kinetic energy is zero. That means which is getting converted completely into the potential energy here in this case. Such a distance is called as a distance of closest approach. During this condition, the alpha particle approaches near the target nucleus and it gets back. So here there is rebounding of the alpha particles. Rebound of the alpha particles. Secondly, if suppose consider a second alpha particle which is moving near the nucleus, so it just hits the surface of the nucleus and it gets rebound back due to the presence of positive charge, as well as the charge which is present on the alpha particle is also considered to be positive. So positive charge, when it goes near positive charge, what happens? It just ripples. So that was the general consideration we just take. Suppose if the alpha particle is positive, nucleus is also positively charged. That is why as it approaches near, it just passes away. That is, it is getting deflected by more than 90 degrees. So here, and coming to the third one, that is the third alpha particle, as it moves, again it gets deflected. So these deflections are done in a hyperbola condition. Okay, it makes certain angle theta. So here we have the impact parameter. So this distance is given by impact parameter, call it as B. Okay, so what is B? B means it is known as impact parameter. And what is meant by D? D means it is distance of closest approach. So later onwards you will study what is impact parameter. So this is all about the trajectory, that is the path taken by each and every alpha particles in that experiment of alpha ray scattering experiment, which was held by Rutherford with the help of Geiger as well as Marsden. Next is alpha particle 1, whichever I had explained, that is same thing is given over here. Kinetic energy is half mv square, moving directly towards the nucleus. As alpha particle approaches the nucleus, what happens? The kinetic energy decreases, potential energy increases. So alpha particle will have kinetic energy of certain value. At the distance of closest approach, its kinetic energy becomes zero, potential energy increases. It is getting transferred, that's all. Alpha particle at a particular distance D, the same thing is repeated over here. Nucleus, its kinetic energy is zero. Particle retraces the path at an angle of 180 degree. Okay, it passes at an angle of 180 degree. There are certain conditions wherein the particles travel more than, particles take a deflection that is more than 90 degree, or else it will follow back to 180 degree. That means it rebounds. Okay, so next is the potential of the alpha particle at D. So what happens to the potential at this condition? According to electrostatic condition, we have studied that the potential U is the potential to be mentioned. U is equal to 1 by 4 pi epsilon naught, and the value of alpha particle is nothing but it is E, and the charge on alpha particle as well as the charge on nucleus. Suppose if charge on alpha particle be 2e and the charge on nucleus be Ze, that is positive, then it is separated by certain distance. And what is that distance? It is distance of closest approach D. Okay, alpha particle as it is coming here, that distance of closest approach is mentioned as D. So the distance between the nucleus as well as alpha particle, we have D, distance of closest approach. So this is the potential of the alpha particle, but at certain condition, kinetic energy is seen to be equal to the potential energy. Loss in kinetic energy is equal to gain in potential energy. So you can just write K is equal to the potential. Kinetic energy is equal to potential energy, wherein you can give K is equal to 1 by 4 pi epsilon naught Ze square, that is 2Ze square divided by D. So in order to calculate distance of closest approach, you have d is equal to take this towards other side and bring back k here. So 1 by 4 pi epsilon naught 2 square divided by k will be your formula in order to calculate the distance of closest approach. Later onwards, alpha particle to what happens to alpha particle, that is the second alpha particle, it approaches the nucleus with a small impact parameter. Only the first one gets deflected like for 180 degree. The rest of the things above the nucleus, there will be certain distance, that is there is a perpendicular distance of each and every trajectories as given over here. That is second is at certain distance from the center. If this is the center, third one is having certain distance, fourth line is having certain distance, fifth is having certain distance. So it is always the perpendicular distance from the center. If this is the center of the nucleus, perpendicular distance is measured in this manner. Okay, so that is said to be the impact parameter. And because of certain repulsion that is known as electrostatic repulsion, it is scattered through a large angle, call it as theta greater than 90 degree. Third alpha particle, as it approaches the nucleus with the impact parameter b, it is scattered through angle which is lesser than 90 degree, as you can see the trajectory image. Okay, so what is meant by this hyperbola? So this can be called as eclipse, this is parabola, and this is the hyperbola which the alpha particle traces. Okay, so here impact parameter, what is meant by impact parameter now? So this is the nucleus. This is an enlarged image of the alpha trajectory, alpha particle trajectories, enlarged image, wherein this is the nucleus, and nucleus has got certain center. That is, we consider the nucleus center point. Okay, so here there is a line which rebounds back. Okay, so the second alpha particle, this is first alpha particle, this is second alpha particle. When the alpha particle starts moving, it repulses. That is, there is a deflection which is taking place with certain angle called as, it makes an angle theta. Now the distance of deviation from the origin line. So what is impact parameter? Impact parameter means the perpendicular distance from the center of the nucleus to the initial direction of the alpha particle. So initial direction was the below dotted lines. So the perpendicular distance from the center, so this is the center, the perpendicular distance from the center of the particle to the initial line, that is these dotted lines are there. No, this is the initial line. Initial direction of the alpha particle when it is at infinite distance from the nucleus is said to be a impact parameter. So how is the impact parameter given? It is mentioned as B. So B will be the impact parameter. Again, suppose you consider a third line which is passing. Okay, so it also has got certain deviation from here, call it as angle theta. So again, impact parameter means it is a perpendicular distance from the center to that third line, that is the initial direction of the third alpha particle. So that is all about the impact parameter. For direct or head-on collision, the impact parameter is 0 and scattering angle is 180 degree. Because alpha particle, that is first alpha particle, as it moves and it comes back again. That is because which is a perpendicular distance for the first one, it is the same here. The direction is this and the perpendicular distance is this from the center of the nucleus. So the impact parameter is said to be 0 and the scattering angle is 180 degrees for the one which is rebounding backwards. So that is all about your impact parameter. So the definition of distance of closest approach and impact parameter are the important concepts for 1 mark. Coming to Rutherford atomic model, he was Ernst Rutherford, a British scientist who conducted experiment based on this atoms. Okay, so by that he gave a Rutherford atomic model which we studied earlier. So according to that model, atom consists of a nucleus which is concentrated in a center with a positive charge and an electrons are the one which starts revolving around that nucleus. That was a concept which was given by the Rutherford. So in today's class, we have studied regarding the introductory part of atoms, from where atoms was derived, and the conclusions which was given by different scientists, and from there we just picked up Rutherford's idea about J.J. Thomson's plum pudding model, that is alpha ray scattering. We studied the setup, we studied the procedure, observation, and what happens in deep, that is alpha particle trajectory, what is the path it is taking and how is the path defined, and the distance of closest approach and the perpendicular distance, which is known as impact parameter. And finally we came to the Rutherford's conclusion, the complete conclusion, which was like the nucleus is as a center and the electrons revolve around the nucleus. So these were the concepts which we had studied today, and let us all meet in the next class in the upcoming sessions of the same chapter. Until then, have a good day. Thank you.